Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by listing the relevant pKa values for this amino acid and the pH you care about. Write down the N-terminus and C-terminus pKa and any side chain pKa. These are the only titratable groups that matter. Once listed, sort them numerically so you can compare each pKa to the target pH. This quick setup prevents mistakes. Make sure to note whether the residue is in a peptide, termini shifted, versus free amino acid, because that changes which pKa values. Now determine the protonation state of each group by comparing pH and pKa. If pH is lower than a group's pKa, that group stays protonated. If higher, it is deprotonated. Translate protonation into charge. For side chains and termini, know their charged forms. Acidic groups are neutral when protonated and -1 when deprotonated. Basic groups are +1 when protonated and neutral when deprotonated. Once done, note each group's charge explicitly so you can add them without confusion. Finally, add the charges from every titratable group to get the net charge at your chosen pH. If a pKa is within about 1 pH unit of your target, use the Henderson-Hasselbalch equation to estimate fractional protonation and include that partial charge. Once summed, report the net value. If something looks wrong, recheck whether you used free amino acid pKa values versus those shifted in peptides, and confirm you didn't flip protonated versus deprotonated charge signs.
Thanks for watching. Subscribe to keep your life in tune.